Hello everybody, and welcome to the last video on Introduction to Integration. We're going to look at one more example of using integration and applying those rules that we learned. So the rate at which the volume of a sphere is increasing is given by the derivative of volume with respect to time, which is 2 pi times 4t squared plus 4t plus 1, and we have an interval, a time interval. And we're also told the initial volume. So we need to find the volume of the sphere when t equals 3. Very similar to our last example, we started with the rate of change. So if we want to know the equation for finding the volume, we need to take the integral of this. The integral is, for the integral, I'm going to start by pulling out that coefficient 2 pi and taking the integral of this expression individually. Remember that I can take the integrals of each term and add those integrals together. So the integral of 4t squared, I'm going to pull out that 4. The integral of t squared is t cubed times 1/3. So that would be 4 times 1/3, or 4/3 times t cubed. Here, the integral of 4t is going to be 4 times t squared times a half. So 4 times a half is going to give me the 2 times t squared. And the integral of 1 is just going to be t plus c. So I have this big expression here, and I could double check if I took the derivative of this, would I go back to this expression? And the answer is yes, I would. Now, I need to find the value of c because this equation is not useful without that. So I know that v at 0, the initial volume was pi. So if I plug in 0 for t, it's going to make this 0, this 0, this 0. So I'm just going to have 2 pi times c. And if I isolate for c, pi divided by 2 pi tells me that c is 1/2. So now I have a volume equation that says the volume of the sphere is 2 pi times this long expression, and I've replaced c with 1/2. Now if I want to find the volume at time 3, I can just plug in 3 wherever I see t and solve for the volume. I end up with 115 pi centimeters cubed. And I'm just going to stop there. I don't need to multiply by 3.14 unless there was some sort of practical application beyond this. Thank you, and have a great day.